Hi, and welcome back. I'll take you through this lesson on statistical analysis and business applications. In this lesson, you'll learn to define statistics and differentiate between statistical and non-statistical analysis. You'll also learn about the two major categories of statistical analysis, namely descriptive and inferential analysis, and their differences. You'll also be able to describe the statistical analysis process and calculate mean, median, mode, and percentile. You'll also be able to represent data distribution using various methods such as histogram, bell curve, and kurtosis. You'll also learn about hypothesis testing, chi-square test, types of frequencies, and correlation matrix. Let's begin this lesson by defining the term statistics. Statistics is the study of the collection, analysis, interpretation, presentation, and organization of data. It's widely used to understand the complex problems of the real world and simplify them to make well-informed decisions. Several statistical principles, functions, and algorithms can be used to analyze primary data, build a statistical model, and predict the future outcome. Statistical analysis is scientific, based on numbers or statistical values, and provides complete insight to the data. Non-statistical analysis is generic information and does not include any statistical or quantitative analysis. Although both forms of analysis provide results, quantitative analysis provides more insight and a clear picture. This is why statistical analysis is important for businesses. There are two major categories of statistics: descriptive analytics and inferential analytics. Descriptive analytics helps organize the data and focuses on the main characteristics of the data. It provides a concise summary of the data. You can summarize data numerically or graphically. For example, you can collect all the data about the visitors to your website for a week and summarize the data. Inferential analytics generalizes the larger data set and applies the probability theory to draw a conclusion. In this approach, a random sample of data is taken from a population to describe and make inferences about the population. Inferential statistics is valuable when it is not convenient or possible to examine each member of an entire population. Let's understand both categories better through an example. Suppose you want to study the height of a person in an entire population. You can do this in two ways. Were you to record the height of each person in the population, it would be a tedious process. Instead, if you categorize height as tall, medium, and small, and then take only a sample from the population, this is an inferential analysis. In the descriptive analysis method, you would record the height of every person in the population and then provide the data for the maximum height, minimum height, and average height of the population. The second consideration is to document the questions. Prepare the questions that you will ask the population of the study in advance. The third consideration is to define the population of interest. Select the population for your study based on the purpose of your analysis. Determine the sample that you want to draw from the population based on the purpose of your study. Let's understand population and sample through the visual. Population consists of various samples. A sample is the part or piece drawn from the large population for statistical analysis. It can be treated as a subset of the population. A sample should be random to help ensure that it has all the characteristics of the population and is also representative of the population. Let's understand the terms statistics and parameters, which we'll be using throughout this lesson. Statistics are quantitative values calculated from the sample. Parameters are the characteristics of the population. Suppose you have x0, x1, x2, and so on until xn, a sample from a population, and you want to know some vital information such as average, most occurring characteristic, and so on. These are calculated using formulas displayed on the screen. Mean is the average, a typical value present in the distribution, and is calculated by summing the values and dividing them by the number of values. Variance measures the sample variability. Standard deviation explains how spread out the data is from the mean. The greater the standard deviation, the greater the spread in the data. It's measured in the same units as the mean. Certain terms are used in statistical analysis to understand the data and gain insight into it. Some of these terms are as follows. Search. Search is typically used to find unusual data. Unusual data refers to those data that doesn't meet the parameters set at the beginning. Inspect. Inspect refers to studying the shape of the dataset and determining how spread out it is. Characterize. Characterize determines the central tendency of the data. Conclusion. Based on the understanding of search, inspect, and characterize, we can draw some preliminary or high-level conclusions about the data. The first step is to find the population of interest, which is closely tied to the purpose of statistical analysis. The second step is to draw a random sample which is representative of the population. The third step is to compute sample statistics to describe the sample in terms of spread and shape of the dataset. The final step is to make inferences using the sample and calculations and apply them to the population. We need to understand data distribution to carry out the statistical analysis effectively. Data distribution is the collection of data values that are arranged in order along with their relative frequency or occurrences. To understand any kind of problem, it's important to describe the data in terms of its spread and shape using graphical techniques. Range of the data indicates the quantitative values, minimum and maximum. Frequency of the data indicates the number of occurrences of any particular data value in the given dataset. Central tendency indicates whether the data values accumulate in the middle of distribution or toward the end. Following are the measures of central tendency. Mean, the sum of all the values in the dataset divided by the number of values. Median, the data value right in the middle of the dataset or the 50th percentile. Mode, the data value which is the most common or frequent. Let's understand percentile in data distribution. A percentile or a centile is a measure used in statistics indicating the value below which a given